All right, so we are on 2.2.2 today, and this book has certain lessons that they call anchor lessons, and this is one of them. That means this is really important. This is like the lesson of the chapter. It's actually this one and the one after it that we're going to tackle on Wednesday. So I'm super glad that you guys are here today and everybody's feeling energetic and ready to go, because this is key to understanding what we're doing in chapter 2. We're going to be working on the big race problems. There are 4 big race problems, which is convenient because the packet that you just got has how many graphs in it? 1, 2, 3, 4 of them, right? We're going to tackle 2 of these problems in class today. I'll do the first one with you, so we're all going to work together on the first one. The second one, I'm going to have you work on your own or with a partner somewhere in the room. The third one's going to be part of your assignment for today. Some of you are going to get started and maybe even finish that today in class. And the fourth one, the final one, we're going to be doing on Wednesday. And Wednesday is a half day, so it's good that we only have one problem to worry about. Okay. So that's what we got going on. That also means it's super, super important that you keep track of this thing and bring it back on Wednesday. I do not have extra copies and I'm not going to make them. So make sure you bring it back on Wednesday. Okay. So let's get started on it. We're going to do problem 53, which is the big race heat one. We'll do what we normally do when we read. I'm going to ask for a volunteer to read the first 1 or 2 sentences. When they finish, they'll pick someone else to read after that. Remember, if you do not feel like reading and someone picks you, just say pass and pick someone to replace you. Okay? That's okay. Sometimes we have days where we just don't feel like doing it, and that's all right. Can I get a volunteer to get us started right here where it says before a big race? Do we have any volunteers for reading? Thanks, Yesenia. No worries. It's preliminary, like the beginning. Thank you. It's your call. You can pick somebody or you can read one more sentence. It's your. Oh, thank you. Nice job, thank you. Could you pick somebody to pick up in the first heat? Are you Ellen? Thank you.
In the first heat, Leslie, Kristen, and Evie both pressed goals towards the. Leslie began the starting line and rode at a constant rate of 2 meters every second. Kristen got an 8-meter head start and rode 2 meters every 5 seconds. Evie rode 5 meters every 4 seconds and got a 6-meter head start.
All right, thank you so much for that. Okay, so let's go to our packet here, and we're going to put some stuff kind of down towards the bottom. Let me adjust my camera here so you guys can read all this. So we're going to go back and reread those last couple sentences, and we need to pull out the important numbers for it. Now, we've been talking about linear functions, and in situations with linear functions, we want to talk about 2 specific numbers. For each of these people, we want a start value and a change value. So can you write those 2 words down next to Leslie? Leave some space to put some numbers after each of them. I'm going to read a sentence about Leslie, and I would like you to listen for some numbers and see if you can figure out what is Leslie's start value and Leslie's change value. All right, so going back to the sentence here, oops. Leslie began at the starting line and rode at a constant rate of 2 meters every second. All right, so where do you think Leslie's start value is? 0, because she started at the start. The start is usually 0. I like it. Let's go 0 for our start. And what about Leslie's change? Must be 2 meters every second. That's great. All right, let's do the same thing for Kristen. If you could write down the words start and change. And then I'm going to read Kristen's sentence. You have the writing utensil? Okay, so Kristen got an 8-meter head start and rode 2 meters every 5 seconds. Kristen got an 8-meter head start and rode 2 meters every 5 seconds. So what is Kristen's start value? She started 8 meters into the race. And how about her change? Change is 2. It's close to 2. Let me read it again. Kristen got an 8-meter head start and rode 2 meters every 5 seconds. 2 over 5. For those with a calculator, could you give me that as a decimal? What is 2 over 5 as a decimal? That's 0.4. 0.4. So her speed is actually 0.4 meters per second. I would probably express it as 2 over 5, though, in terms of a slope. Same thing, though. All right, one last racer here. This is Evie. If you could please write down the word start and change, and then I will read the sentence. As you hear those numbers, be prepared to fill those numbers in the right place. All right. Evie rode 4 meters every, I'm sorry, let me start again. Flip my numbers. Evie rode 5 meters every 4 seconds and got a 6-meter head start. Evie rode 5 meters every 4 seconds and got a 6-meter head start. What was Evie's start value? 6. And her change? 5 over 4. And let's get that as a decimal. It might be useful to us. What is that speed? 4.25, if you put that in, or 1.25. You put it in your calculator, you got 1.25 meters per second. All right, now we're going to graph these and we're going to answer a bunch of questions, but I have a question for you right now. They didn't ask us in here, but which racer is going fastest? Leslie, Kristen, or Evie? Leslie. Leslie has a speed of 2 meters per second. Clearly faster than Kristen and Evie. Between Kristen and Evie, who's faster? Evie's faster. And Kristen has the slowest speed, so Kristen's going to be the slowest. However, some of them have different head starts, so maybe the head starts will come into play. So we don't know for sure who's going to win just yet. All right, any questions so far? Say again. Depends on how long the race is, yeah. So we're going to graph. And when we make a graph of an actual situation, it's usually a good idea to label our axes. So let's label the x-axis down here as distance. Distance, no, I'm sorry, I flipped it. The x-axis is time. Sorry, erase that, please, or scratch it out. Time. And what units are we measuring our time in here? What units did you see pop up in the explanation? Was it weeks or days or minutes, seconds? Time is in seconds. And then the y-axis is going to be distance. What distance units were you seeing in our reading there? Distance in meters. And we said 0 was going to be the starting line. Has anybody read ahead into parts A, B, C, D, E yet? Did anybody figure out how far the race is? Well, you don't have a book. That would help. How far is the race? 20 meters. They tell us in part C that the race is going to be 20 meters. So this is our finish line. All right. Well, let's get started graphing here. So I'm going to graph Leslie first. I'd like you to do this too. I'm going to color code mine, but you could code yours with like a solid line for Leslie and a dashed line for Kristen and a dotted line for Evie, however you want to do it. Leslie starts at 0. So at time 0, she's at 0. So draw that first point there at 0. Her change is 2. We could also write that as 2 over 1. So let's do our rise over run. Count up 2 and over 1. And then keep doing that and get me a bunch of points. Let's go right off to the edge of the graph, and then we'll grab our ruler and draw that line through these points. And that's our Leslie graph. So I'm going to put a little L here. So I know that's Leslie. All right, who's up next? Kristen's up next. Kristen starts at 8 and her change is 2/5. So get Kristen started off at 8. She's starting 8 meters into the race. And her speed is 2/5. So up 2/5. Boom. Up 2/5. Up 2/5. And we'll just keep going until we get Kristen out to the finish line. We'll draw a line and we'll label that K for Kristen. And then we'll do the same thing with Evie. Pencil, come on. Stick with us here, please. Evie's got a start value at 6. So draw that first point here at 6. There you go. In here. Okay, thank you. And Evie's change is 5/4. So from there, go ahead and count up 5/4. Up 5/4. Up 5. Ooh, that takes me off the graph, but that's okay. I can kind of fake it. Over 1, 2, 3, 4 would be about there-ish. And we'll draw a line for Evie. Didn't quite hit all my points there. Oh well. Yeah, it's more the lower one than the upper one. All right. Yeah, you want to be careful about drawing your lines. The more accurate you can make your lines, the better for these. All right, that was Evie. All right, I think we're in good shape here. Kind of lost this point here. There we go. All right, let's see where we're at. I'm going to read part A. It says on neatly scaled axes, graph and then write an equation for Leslie, and then do the same for Kristen and Evie. Well, we already graphed all 3 of them. That's great. Let's write equations for all 3 of them. Let's go down below where we've got our information. I think we've got all the information we need to write equations, don't we? All we need is a change in a start value. So Leslie is y equals something x plus something. What 2 numbers are going to go into that equation? 2 and 0. We just got to get the right one in the right place. So y equals 2x plus 0 for Leslie. I might actually write that y equals 2x instead. It's the same thing. It's a little bit shorter, a little bit more simplified. For Kristen, let's write an equation for Kristen. So y equals, Kristen's change was 2/5. X comes after that change and then a +8 at the end because that was her start value. If you'd prefer to use that 0.4, that's okay. That works also. 0.4 is the same as 2/5. And Evie's equation would just be y equals 5/4x plus 6. We're just putting that information together from the start value and the change. Guys, we're doing awesome. Does anybody have any questions before we move on to part B? Big important question here for part B. I'm going to put the graph back up so we can see it. This question is about Leslie and Evie. So focus on the purple and the red graphs here. And it says, after how many seconds did Leslie catch up to Evie? So see if you can find me a place on the graph where Leslie and Evie were side by side. They were right next to each other. They were the same place in the race at the same time? Can you find me that spot on the graph where Leslie and Evie were in the same place at the same time? I'm hoping that you're looking at this point right here where those two lines cross. So the question was, how many seconds did it take for Leslie to catch Evie? How many seconds into the race did this happen? It happened 8 seconds into the race, right? So let's write ourselves a little sentence here. Leslie, I'm just going to use initials here. Leslie caught Evie 8 seconds into the race. Leslie caught up to Evie 8 seconds into the race. And it looks like Leslie passed her because before that, Leslie was behind, and after that, Leslie was ahead. There's a follow-up question here. It also says, how far were they from the starting line when Leslie caught up to Evie? How far away from the starting line did this happen? 16 meters into the race? Yeah, 16, right? So I could say it happened 16 meters from the start. I meant to say it happened. It happened 16 meters from the start. All right, that takes care of part B. Part C. Who won? Leslie won? How can you tell Leslie won? Closest to zero where? Which point are you looking at? This down here? The bottom line? Okay, this is the starting line. When we're talking about the winner, if you're watching for the winner of a race, are you looking at the starting line or the finish line? We need to be looking at the finish line, don't we? Do you still think Leslie won if we're looking at the finish line? Yes? How can you tell me? What do you see happening on our finish line here that tells you Leslie won? She was the first one to cross, wasn't she? How long did it take Leslie to finish the race? 10 seconds. So Leslie finished in 10 seconds. And this is actually the last problem asked, or part D asks us how long did it take for each person to finish. So let's go ahead and do that. Leslie finished in 10 seconds. Now, Evie wasn't far behind her. Evie finished after. Now, when I took my time and drew this a little bit better, it's somewhere between 11 and 12 seconds. I'm going to say like 11 point, I don't know. What do you guys think? 11.5? 11, sure. I don't know. 11.5 seconds. Only 1.5 seconds behind. And what about Kristen? How long did she take to finish? 30 seconds. All right, guys, we're doing great. We're almost there. Part E says the school newspaper wants you to report Kristen's speed. How fast was Kristen riding? I think we already did this, didn't we? Yeah, how fast was Kristen going? I've already got it on my page. Kristen was going 0.4 meters per second. Yep. However, that's not the story I would report. If I watched this race and I were reporting on this and I wanted to talk about Kristen, what awesome thing could I say about Kristen? Kristen did not win the race, but I think Kristen is pretty awesome. Slow and steady, right? She knew she was going to lose, but look, Kristen saw these two people finish the race like 20 whole seconds before she did. She was only like almost halfway into the race when she watched the other two people go across the finish line. Did she stop though? No, she kept going and she finished the race. That's pretty cool, right? That shows tenacity, right? She's like, I'm not going to win, but that's all right. I'm going to finish. And I think that's pretty awesome. So if I were writing a story about Kristen, that's what I'd be talking about. Yeah, she finished later than everybody, but she got there. She made it. All right. So I told you we were going to do one together and then you were going to do one on your own. So if you flip the page, you're going to see basically the exact same thing, except you got some different names down at the bottom: Elizabeth, Kay, and Hannah. Where do you suppose you're going to find information about Elizabeth and Kay and Hannah? And the next question in the book. You found it already, huh? I want to give you a couple heads up on this. For Kay and Elizabeth, they actually gave you equations. You're going to find their start value and their change from the equations. For Hannah, they gave you a table. Now, there's a couple ways you can go about this, but we know how to find a slope from a table. We practiced that. We put some notes in our packet today. I would recommend that when you go to find your start value for Hannah, that you graph a couple points on this and very carefully line your ruler up and draw a line, okay? If you need any help with part C when you get to Hannah, just raise your hand. One of us will come around and give you some hints on that. Folks, before you leave today, I want you to have Heat 2 finished. If you do get it done, please raise your hand so I can check it over. And then as soon as you finish that, you can go ahead and start on the assignment. The first problem in the assignment is number 61, which is actually Heat 3. So you might even be able to get 2 more graphs done today. We got a pretty good chunk of time. At this point, you are free to move about the cabin. If you would like to sit in a new location, that's fine. I don't want to see any groups bigger than 3, though. Okay, 3 is the maximum group size. Please let me know if you have any questions. Your goal today is to finish Heat 2. All right, get after it, guys.